Welcome. Uh, Today's topic of discussion is break-even analysis. So let's begin. So one of the first things which we learn in break-even analysis is there are three factors or three things which determine our final outcome. So these things are fixed cost, the variable cost, and the profit. So definitely in any industry we are or any factory we are concerned with what are the costs involved in setting up the factory? What is the cost involved in setting up the machines, in hiring the labor and maintaining the labor and how to manage their over time and so on. So everything is managed in accordance with whatever output we desire out of the system. So in a break-even analysis, first we take into account what is the break-even graph. So like basically continuing from where I left off in the previous video, that if there are some sales happening in the company. Let's say that is shown on the y-axis. Corresponding number of units sold is X. And let's say the sales price per unit is is shown by smallest. So if smallest shows as the sale price of one unit, we would know that S into X, that would be the total sales achieved uh, in the factory or in the wherever the sale is happening. So basically, if this graph we draw, that is somewhat like a straight line whose slope is smallest. Right. So this is what I was talking about in the last video. That this happens quite in terms of theoretical terms. Yes, that is correct. If there are X items sold, then there would be S sale items. Right. But if this was replaced by some kind of time axis, then it won't be so necessarily. That is one thing. And next, we want to evaluate in any factory how we determine at which point we are going to turn profitable. So that is a key point in determining what is the course of any products. By which I mean how we are going to conduct the business of the factory, the day-to-day workings of the factory, and the strategic planning that in 1 month or 6 months how we are going to operate, and then the long-term planning that how we are going to increase the space of the factory, how we are going to get the factory developed, what is going to be the future hiring of the factory, what is going to be the future technologies we would need to improve the efficiency of our process. So we have fixed cost. Fixed cost is represented by FC in short. We have variable cost. Variable cost per unit is represented by small v. This is variable cost per unit. Cost per unit. FC, this is the fixed cost. Let's say this is represented by F, fixed cost. Just to make it even more shorter, we have represented by it by capital F because it's like cost only. So this is F, fixed cost, or what we say factory cost. This is variable cost per unit. So unlike variable cost, fixed cost is for the whole production, right? No matter how many units we are producing, it is a given or it is a constant. We are producing 1 unit, that would be there. If we are producing 1,000 units, it would be the same thing only. So it is independent of the number of units which we are producing. So this is one of the important factors in determining how much capital is required in beginning the production of a system. Next, we say what is the total cost. So total cost, let us represent it by T. So we can say this as total cost. S, we are saying represents the sale. So for that, we already know what is the formula. That is small s into the number of units sold. So what would be the total cost? Total cost would be capital F plus variable cost into the number of units X. So uh, that is the main formula which you are looking for. That the total cost in production of X units is fixed cost of the system, that is F, and the variable cost into the number of units produced. So X is the number of units we are produced, and V is the variable cost per unit. Small s is the sale price per unit. Next, we want to draw a graph. So plotting the total cost of the system with the x represented by the horizontal axis and the cost or revenue represented by the vertical axis. So we say that the total sales are represented by this blue graph, this blue line graph, which passes through origin. And we have this graph which starts from somewhere above the origin and intersects our total sales line. This is the sales line and this is the cost line, right? So where the sales and cost intersect, so this is the sales. So it is coming very faintly. Let me just draw it one more. So we'll say, okay, this is the point before which the sales which we are able to get for our product is less than the cost. So this is the region of loss making region. And for beyond this point where the sales have exceeded the cost for the product, this is the region where we have profitability or simply profits in the system. So that's what any business is all about, profits and loss. Mainly, profit in any kind of business is based upon the idea that we are producing something out of raw materials, converting those raw materials into some output, which will be a value through which process we have done some value adding process to the raw materials. Anything which we are doing, which we are producing, any services which we are giving to the customers, to the consumers, it is a value addition process. It adds value to the system. Even a simple process like, let's say, the fast delivery system, which we have operating today in any kind of major city or town, where the products are delivered relatively very quickly, even in 10 minutes and so, which was not imagined a lot of time ago. So there, the value addition process which we are producing to the customers is the time saving cost. that the time required by the customer to acquire that particular product is saved. So that is the one value addition process. Um, and also we are saving the customer's fuel and other miscellaneous costs, which the customer has to basically expend while they are uh, out there and buying whatever product which they want. So earlier, when the customer behavior was such that the buying process or buying the essential needs of the thing of the objects was a secondary reason, and the main reason was going out and basically having a good time. So when that particular thing has diminished and the main need of acquiring the essential products was identified, then that particular thing was improved upon. That how can we improve that particular point for a certain section of what we say population. So there also in those kinds of business also we first identify at what point the business or the whatever services we are producing to the customer they will turn profitable, how our sales are going to increase and they are going to they are going to be uh, more than the cost we are expending in sending the product from the delivery point, from the cloud delivery station to the point where the customer is able to the customer's home. So all those things require this analysis only. That at certain point where the market has reached some certain amount of products with which they are with which uh, they are acquiring, then we will say that yes, at that point the business can turn profitable. So everything is then affected by this fixed costs which we can reduce and the variable costs which are growing. So this is what we are going to analyze. Okay, what is this break even point? That is what is this X is in any kind of business. What is that break even point? So let's say let's mark it as XB, break even products. So we will say when the sales of the product, that is S into X, is exactly equal to the cost of the producing that X products. At that time, we will say the amount of products which we are selling or which we are producing, that becomes the number of break-even products. That is when sales equals the cost. So at that point, do you think there would be any profits? By which I mean is that what is happening now is that whatever cost which we are producing, expending in transporting the goods to the end consumer, all those logistics costs they combine to give us some sales which are matching our cost. So there is no profit for us. This is a no profit, no loss business. So in that case, XD is equal to uh, S minus V. So that would be our what we say numerator XB into S minus V is equal to the fixed cost or the number of break-even products is equal to fixed cost divided by S minus V. Remember that these are small s, that is sales per unit cost and variable cost per unit. So this is the number of products on break-even point produced. We can also analyze further exactly what is the break-even sales. So break-even sales would be simply multiplying the break-even number of products with the sales cost per unit. It is simply F into small s divided by S minus V. So small things like that we can easily calculate. Uh, Next, we want to start with the next idea, that is contribution margin. So contribution margin, I hope it is visible, whatever is being written. So this is contribution margin. So contribution margin of any product, we say it is equal to uh, the total cost or the total sales, total cost I is saying, sorry, total sales which we have achieved in our production minus the total variable cost. So here I would like to take a pause. What is total variable cost? Total sales we already know, that is small x into x. What is total variable cost? Total variable cost is represented by V. That is capital V, and it is equal to small v into x. That's its value. This is the total variable cost which we have expended in uh, creating our product or achieve our production. So this is equal to contribution margin represented by Cn. Total sale is simply S into X, small s into X, and we subtract it. If we get small s minus V into X, this is the contribution margin. So this is one kind of basically we say um, parameter which shows us that our system is profitable at what point. So that is the break-even point, right? So it helps in achieving showing that what that break-even point is. Then we have one more quantity called contribution. Contribution is simply uh, contribution margin divided by the number of products which we have sold. That is S minus V only. Or we can say total sales minus the variable cost divided by X. That is what contribution is. So these are the same things which show us that whether our business will be making profit or no. Okay. So now let's draw a profit loss graph. So profit loss graph shows that if we are producing some X amount of products, then whatever graph which we are drawing before the break even point, that is XB, we will be making loss, and beyond that point we will be making a profit. So basically this vertical line shows us whether we have a profit or loss. So it is some kind of what we say represents some money on y-axis. On the x-axis I have this number of products sold. That is what profit loss graph is. The slope of this graph is that same thing, that is S minus V, contribution. So that's like an important thing, S minus V. Next, we have what is profit volume ratio. Profit volume ratio. So this PV ratio is basically uh, the products which we have uh, sold, the whatever products which we have sold, this is S minus V into X. So that is contribution margin, right? Products, one number of products which we have sold, that comes in numerator because V is volume. The volume is in denominator here, so we have number of products sold, that is in denominator, and that is also multiplied with the sales per unit. So total sales and denominator, contribution margin and numerator. That contribution margin divided by sales, that is our PV ratio. So this PV ratio is basically S minus V divided by sales cost per unit product, that is smallest. So this is one of the uh, ways to identify the products which will generate maximum profit for a given sales. So if this PV ratio is high, that means that if we are putting some X amount of money to, or we are getting some X amount of revenue from some product, then it will be generating some profit. And there is some other product whose PV ratio is either more or either less than that original product, then its profit would also be either more if its PV ratio is more or less. If its PV ratio is less than that of the original product. Next, we have a margin of safety. Margin of safety is basically saying how much sales is we are exceeding from the total cost of the production. So is basically sale which we are having currently minus the sale which would be having at the break even point. So this is called margin of safety or MOS. So whatever sales which we are having at break even point, that you already know, it is F upon S minus V into sale per unit product, that is S. And whatever sales we are having currently, that would be some sales and at the sales per unit product at the current point into the number of products which we are selling currently. So that is S into small x minus F upon S minus V into S. So this is margin of safety. That means if our sales fall, this is the gap which we have with which we can sustain our business profitably. So now let's move on to some questions because those are actually the best way of learning any kind of theory which we have been learning. In theory, which we have developed some ideas. Okay, this is what break-even analysis is. This is what we do, and this is its supposed use. But when we have to take some decisions, what is the kind of questions which we face? So let us start with a question where we have four products in front of us. Products one, two, three, and four. Each product has some fixed cost and a variable cost. So these are the products. Let's say the products are one, two, three, and four. Fixed costs are F, and variable cost is small v. So the fixed cost of a product is basically we say, uh, let's say it could be some 10 rupees or 20 rupees, something like that. And variable cost would be some like 1 rupee, 2 rupee per unit product. So the fixed costs are for first product it is some 20 rupees, 20 rupees, 30 rupees, 10 rupees, and 40 rupees. We are producing our product through these different processes. So each process has a different fixed cost. This product has a fixed cost of 20 rupees. This product has a fixed cost of 30, 10, and 40. A variable cost of producing the product through process number one is 3 rupees. Through process number two is 2 rupees. Through process number three is 4 rupees. And through process number four is 1 rupee. So our objective is to find what would be the most preferred process for producing some 10 or 100 units of product. If I want to produce 100 units of product, which would be the preferred process? So as what I've analyzed, I was earlier saying 10. So if I were to produce 10 products, I can simply say, okay, 10 products which we are producing multiplied with the variable cost of process 1 would be 3 into 10, so it would be some 30. So 30 plus 20, that would be 50. Then we have 2 rupees for second, so it would be 2 into 10, 20 plus 30, again it would be 50 rupees only. For the third product, it would be again 50, and for the fourth product, it would be again 50. So what about 100? For 100 products, you would say it would be 20 plus 300 because 100 into 3, 30 plus 200, 10 plus 400, and 40 plus 100. So the minimum cost which we are achieving is in the third product process, that is 140 rupees. So we will select the process assuming that in all the products we are achieving the same quality. The quality achieved in producing all the four products is same. So even though the cost may seem starkly different, the cost here is some 500, the cost here is only 140. They're still achieving giving us the same customer satisfaction to the end user. So we won't say we are losing customers to some other producer who is producing the same product at some other quality. Next question which we have is slightly will have some slight calculation. So basically that question which we have is of decision making. So it's also a good question which we have basically a product which we have to produce, but we have three ways of producing that product, right? So there is a fixed cost F and the three ways which we can label as 1, 2, and 3. We don't have any fixed cost in producing through way number 1. The variable cost, small v, is 10 rupees. Fixed cost in producing the product through second process is 3,400 rupees. So it is basically saying that you will have to procure a semi-automatic machine. So you will have to pay this much amount of money upfront, but the variable cost would be lesser. Its value would be some 6 rupees. Then we can have a fully automatic machine as well to produce our product. And the fixed cost is some 20,200 rupees, and the variable cost is 3 rupees per product or per unit of production. So what should we do? So this is kind of a good problem, right? Because here we'll be doing some kind of programming. We do not know, okay, how much products which we are going to produce, which is like most of the cases, which is like the real life case. So that means that okay, we'll have more than one solution. So that is also a hallmark of any kind of real life system where we see that okay, what amount of products which we want to produce, and according to that, we will say that okay, these are the number of products which we are going to produce. So this is the decision which we are going to take. So let's say we are producing some n amount of products. So in this case, the cost is going to be 10n, 3400n, 3400 plus 6n, and 20,200 plus 3n. Right. So we'll say 10n is equal to 3400 plus 6n. If I equate these two decisions, then we can say that above that point which we are going to achieve will be having more cost in this decision, right? Because here the variable cost is more, here the variable cost is less. So clearly we can see that if we achieve some kind of intersection, this line will have more slope because it has a coefficient to the along the variable. So we need to get an intersection, and whichever has the highest slope will have the higher cost, which we won't choose. We will choose the one with the lower cost. So if I equate them, I'll get 4n is equal to some 3400. So this n's value would be some 850 products. So that means below 850 items, we must prefer our decision one. We must use this process one. So we'll use process one and we'll say uh, we won't buy any machine, we'll simply buy purchase that unit from a vendor and whatever do some value addition process and sell to the end consumer. If I'm quitting going beyond 850 units, then I would say that okay, now I need to purchase a semi-automatic machine, and I'll say that okay, I'll pay some 6 rupees per unit to the labor to produce units whatever are above 850 units. Then what about here? For the third decision, 6 on. So if I subtract this, I'll get 16,800 is equal to 3n. So this is comes out to be some 5,600 units. So again, above this units will select decision 3 because it has lesser slope, and below 5,600 units will select decision 2 because it has a higher slope. That would be more economical there. We can also draw a graph. So this is decision 1, this is decision 2, this is decision 3. First and second was 850, and yes, this is the first one. This is the second graph. Second graph would be somewhat like this. First, second, and third. So this is 850 units, and this is your 5600 units. Decision line 1, decision line 2, and this is your decision line 3. Slope is almost zero for the third decision line. I'll draw it again with the black pen because that is the only one which is visible. Something like that. Last question which we have is that of two machines of the same production base. So that question we will discuss in the next one. But I'll tell you what the gist of that question is. So we have two machines. They are producing the same product, and they are producing the same product at the same rate. So that means that if let's say I produce n items per day in first process, I'll be producing the same n items a day in the second process. Now, in the first machine, what is there is that there is some fixed cost of some, let's say, 20 rupees, and the variable cost is 1 rupee per unit. For the second machine, the fixed cost is 10 rupees, and we have a variable cost of 1 rupee, something like that. So, a variable cost of 2 rupees. So, we have to operate both the machines concurrently. Concurrently means that they will be producing the same, uh, they'll be operating in the same day. So, if we have to find a break-even point for such a system, so eventually we simply will say, okay, the first machine will have this much fixed cost, this much variable cost, we'll add that to the second machine. They'll be producing the same n amounts of units. So n into we'll say n into 1 for the first machine and n into 2 for the second machine. The twist in the question is uh, below some certain units, we have some sales cost, 3.5 rupees. And above 300, 200 units, the sales cost decreases. It decreases to some 3 unit per piece. So, in such a system, how will we find the break-even point? So, we'll discuss it next time. Thank you.